Now in this video I'll talk to you about an important feature of alkenes. In fact, any system containing a CC double bond, that's known as the cis-trans isomerism. Cis-trans isomerism. Remember what is isomerism? Isomerism is a phenomenon where two or more compounds have same chemical formula but they have different structures. Okay, so one isomerism that we've already talked about is the conformational isomerism. Let's talk about another called as the cis-trans isomerism. So for this we use the example of butene, C4H8. Okay, so if we were to draw structures of C4H8, I can draw three structures: CH2, this is my one butene. This one tells me that the position of double bond is at carbon 1. Then I can draw a 2-butene. Okay, and then I can draw a 2-methyl propene, right? So that will look like this. Right, so this will be 2-methyl propene. So this would be my longest chain, right? Propene, and this position is 2, this position is 1, so 2-methyl propene. Okay, take a minute, pause this video and try to draw all these three structures of C4H8. Now we would think that these three are conformational isomers of butene, which is fine. But take a closer look at this structure. I'm going to draw this structure again for you. CH CH3 CH3. Yeah, so this is the same as the 2-butene that we've drawn before. Can I write this structure like this? Okay. What are the differences between these two structures? First of all, these both are 2-butenes. Okay, they both are 2-butenes. But what is the chief difference between these two structures? In this case, hydrogens are on the same side of carbon-carbon double bond, and in this case hydrogens are on the opposite side. Now why is this significant? This is significant because if you try to rotate this double bond, okay, this structure will break. Okay, so carbon-carbon double bond rotation is not possible. On the other hand, if this was a carbon-carbon single bond, you can easily rotate it. Okay, so if you rotate this double bond, the carbon-carbon bond will break. So because of that, this structure is different from this structure. Okay, this structure is different from this structure. So these are known as isomers. Why they are known as isomers? Because they both are having the same chemical formula, C4H10, but they have different positions of substituents, or they have the same formula and connections between atoms, but they have different three-dimensional structures because of the way the groups are attached to the double bond. So three-dimensional structures are different, their connections are same. In this case also, carbon, this the carbon, second carbon is connected to CH3, this also second carbon is connected to the CH3. So connections are same, but three-dimensional orientations of the groups is different, and that way they will be isomers. So this will be known as the cis isomer because the groups are on the same side, cis isomer, and this, the groups are on opposite sides, so this is known as the trans isomer. Okay, now how do we know, or how do we generalize this? So let's write this C double bond, and I'm going to call these substituents A, B, E and D. Okay, and this is known as the end of the chain. This is known as the end of the chain, as in end of the, or end of the carbon-carbon double bond more precisely, and this is known as the side part of the double bond. This is known as the side of the double bond. Now, how do we know if that specific molecule will have cis trans isomer? If A is not equal to B and D is not equal to E, and I'm going to write the word "and" here because it's very important. Okay, as long as A and B are not equal and D and E are not equal, the system will have a cis trans isomeric feature. So the compound will have cis and trans isomers.